If I'm solving a problem involving a linear quadratic system, a Canadian cargo plane drops a crate of emergency supplies to aid workers on the ground. The crate drops freely at first before a parachute opens to bring the crate gently to the ground. The crate's height, h in meters above the ground, and t seconds after leaving the aircraft is given by these two equations. So we have the free fall, h1 is equal to negative 4.9 t squared plus 900, or the height with a parachute, h is equal to negative 4t plus 500. For how long after the crate leaves the aircraft does the parachute open? Express your answer to the nearest hundredth of a second. Well, where this change occurs is going to be, if I was looking at my quadratics, it's going to be where the two intersect, because I'm going to have one that's going to be a parabolic shape, I can tell from here. I'm going to have one that's going to be a linear shape, and then when it shifts from the free fall to the nice smooth one, at that point is going to be where the parachute opens. So I'm just solving for what the intersect point is. I can say that if h is equal to negative 4.9 t squared plus 900, or h is equal to negative 4t plus 500, I can just subtract these equations together to get rid of h. And I'm going to get negative 4.9 t squared plus 4t, remember when you subtract the negative, and then plus 400. Now, because it says solve to the nearest hundredth of a second, and just looking at it, this isn't going to be factorable. So in this case, I'm actually going to use my quadratic formula. I'm going to make my list to begin with. A is equal to negative 4.9, B is equal to positive 4, and C is equal to 400. Which means that t is going to equal the negative of bracket 4 plus or minus the square root of 4 squared minus 4 times negative 4.9 times 400. Remembering to always use the brackets for substituting. All divided by 2 times negative 4.9. I'm going to simplify this and say that negative 4 plus or minus the square root of, in this case, 7,856 is all divided by negative 9.8. Now, I can't simplify this further, so I'm just going to have to solve for the two possibilities. One possibility is that t is going to equal negative 4 plus the square root of 7,856, all divided by negative 9.8. And to the nearest hundredth, I get negative 8.64. Or t is equal to negative 4 minus the square root of 7,856, all divided by negative 9.8. And this gives me positive 9.45. Based on the context of the question, the parachute is not going to open 8.5 seconds before it has left the plane, which means that only this solution makes sense. Now, I know what the t value is, but I still need to solve for what my h value is going to be in this case. So, in this case, I can say right now that the time (9.45 seconds after leaving the plane). The time is going to tell me what the height was. So I can substitute the time back into either of the equations in order to solve this. In this case, I'm going to use the linear equation. It should give me the same answer either way, but I'm going to use the linear equation. So I'm going to say that the height is going to be equal to negative 4 times 9.45 plus 500. And in this case, I get 462.2. Because it wants it to the nearest meter, the height above ground is 462 meters when the parachute opens. When I'm solving it graphically, and yours might look different than mine when you are actually graphing it out, I'm not going to apply the negatives. All I care about are the positive values. So I said that the h is going to be between 0 and 1,000, and that based on the information that I have here, I'm going to make my t values go between 0 and 20. And I get approximately this. My first equation, which is h1 is equal to negative 4.9 t squared plus 900. I'm just going to replace with y1 is equal to negative 4.9 x squared plus 900. And I get something that looks like this free fall. The second equation, y2 is going to equal negative 4x plus 500. And I get something that looks like this. And the point where they cross is 9.452 and 462.19. It's rounded differently, but it gives me the same solution as what I have. For the last example, Terry makes a good hit and the baseball travels on a path modeled by h as a function of x is equal to negative 0.1x squared plus 2x. Ruth is in the outfield directly in line with the path of the ball. She runs towards the ball, jumps to try and catch it. Her jump is modeled by h as a function of x is equal to negative x squared plus 39x minus 378. In both equations, x is the horizontal distance in meters from home plate, and h is the height of the ball above ground. First thing, we're going to solve the system algebraically. So if I know that h is a function of x is equal to negative 0.1x squared plus 2x, or h is a function of x is equal to negative x squared plus 39x minus 378. H is a function of x is the same in both cases, so when I subtract it, they're going to eliminate. I'm going to get 0 is equal to 0.9 x squared minus 39x plus 378. Because it says round to the nearest hundredth, and I could try, but I'm not going to be able to factor this, I'm just going to use my quadratic formula again. I'm going to make my list and say that a is equal to 0.9, b is equal to negative 39, c is equal to 378. So x is going to equal negative of negative 39 plus or minus the square root of negative 39 squared minus 4 times 0.9 times 378, all divided by 2 times 0.9. X is going to equal 37 plus or minus the square root of 8.2, all divided by 1.8. And now I have my two possibilities. Either I'm going to say x is equal to 37 plus the square root of 8.2 over 1.8, which would give me x is equal to 22.15. The second possibility, x is equal to 37 minus the square root of 8.2 over 1.8, which is going to give me approximately 18.96. Both these answers so far make sense given my problems. It could be 18.96 meters from home plate. It could be 22.15 meters from home plate. So there's nothing here that so far looks like it wouldn't work. So I'm going to solve for what the height would be in this case. I'm going to say, well, my first possibility, the height is 22.15. And it's going to be negative 0.1 22.15 squared plus 2 times 22.15. The height at 22.15 is equal to negative 4.75. This doesn't make any sense given my problem. If that's the height above ground, I'm not digging into the ground. What about the other possibility? The height, where it's 18.96, is equal to negative 0.1 times 18.96 squared plus 2 times 18.96. This gives me 1.96, which could be possible. So I wind up with the solution of 18.96 and 1.96. Based on the context of the question, when it says explain the meaning of the point of intersection, it just means write as a sentence what the solution of this would actually represent. Ruth caught the ball (18.96 meters from home plate at a height of 1.96 meters above ground. And that's it.